In this video, we will cover section 4.2, solving systems of equations by substitution. Students will be able to solve systems of equations by substitution.
In this video, you will continue to learn about solving a system of equations by substitution. First, let's review the steps. The first step is to choose one equation and solve for one of the variables, i.e., get x or y by itself. Then, substitute into the other equation. This will result in one equation with one variable. Then you're going to solve the equation, substitute your value into either of the original equations to find the other value, and then write your answer as an ordered pair. Lastly, you can check your answer by substituting the point back into the original equation.
Now let's discuss how to choose which variable to solve for in order to use substitution. You essentially want to ask yourself the question, is there a variable without a coefficient? Meaning that it's just x or y. If there is, then you're going to solve for that variable. And if not, meaning use something other, so whether there's a negative in front, a number, you want to choose the other number with the smallest coefficient value-wise, and that evenly divides into all of the other terms, so it works out nicely.
In this example, our two equations are negative 3x plus 2y equals 20 and x plus 4y equals negative 2.
Now, since the variable isn't already by itself, we have to ask ourselves if there is a variable without a coefficient. If so, you're solving for that variable. If not, you're going to select the other variable with the smallest coefficient. However, if we look, we do have a variable without a coefficient being this value of x, so that's going to be the variable we're going to solve for.
In order to do that, you would have to subtract 4y from both sides. So it'll become x equals, and since the negative 2 and negative 4y aren't like terms, they'll just become negative 2 minus 4y. Now you can take this entire expression of negative 2 minus 4y and substitute it for x in the other equation. So it'll become negative 3 times negative 2 minus 4y plus 2y equals 20. Now to solve that equation, you first have to distribute the negative 3, so it becomes 6 plus 12y plus 2y equals 20. Combine like terms to get 6 plus 14y equals 20. Subtract 6 to get the y by itself. So you'll have 14y equals 14, and then divide both sides by 14 so that y is equal to 1. Now you can take this value of y and plug into the original equation. So you'll get x equals negative 2 minus 4 times 1, so x equals negative 6. So the solution to the system is negative 6, comma 1. Pause the video and try the next one on your own. In this example, our two equations are 4x plus 2y equals negative 6 and 8x plus y equals 9.
Now, since there isn't a variable, it's already by itself, we first have to look to see, is there a variable without a coefficient? And if so, we want to solve for that variable. Now, looking at these two equations, I can see in my second equation, I have a variable that is just y, meaning it just has no coefficient, so it's really 1. So we're going to solve for that variable. So in this case, I would subtract 8x
from both sides. So you'd have y equals 9 minus 8x. So you're going to take this entire expression and substitute it for y in the other equation. So it becomes 4x plus 2 times 9 minus 8x equals negative 6. Now to solve, you first need to distribute. So you'll have 4x plus 18 minus 16x equals negative 6. Combine like terms to have negative 12x plus 18 equals negative 6. Subtract 18 from both sides. So negative 12x equals negative 24. And divide both sides by negative 12 so that x equals 2. Now you can take this value of x and plug it into the equation, solve for y. So y equals 9 minus 8 times 2, so it'll give you y equals negative 7. So the solution to the system is 2 comma negative 7. In this example, our two equations are 4x minus 6y equals 16 and 5x minus y equals negative 6.
Now the next thing we have to do is select which variable to solve for, since none of them are by itself. The first part of the question asks, is there a variable without a coefficient? So I have a 4 and a 6 both have a coefficient of 5, and this negative y really has a coefficient of 1. So technically it does have a negative 1, so it's something we have to worry about. However, the second part says, if not, select the variable with the smallest coefficient that evenly divides into the other terms. If we're selecting the one with the smallest value-wise, ignoring the signs, I have a 4, a 6, a 5, and a negative 1. Now this negative 1 is the smallest value, so we're going to select this equation, and also it divides evenly into 5x and negative 6, satisfying both parts of that requirement.
So in order to solve to get that variable by itself, I would first have to subtract 5x from both sides. And again, those aren't like terms, so it'll become negative y equals negative 6 minus 5x.
Now in order to get rid of the negative in front of the y, we know that this is really a negative 1. So this means in order to get rid of it, just like we would any other coefficient, I'm going to have to divide everything on both sides by negative 1.
So it'll become y equals 6 plus 5x. Now I can take this entire expression and plug it in for y in the other equation. So it'll become 4x minus 6 times 6 plus 5x is equal to 16. To solve, you'd first have to distribute. So it'll become 4x minus 36 minus 30x equals 16. Combine like terms to get negative 26x minus 36 equals 16. Add 36 to both sides to get negative 26x equals 52. And divide both sides by negative 26 to get x equals negative 2. Now you can take this value of x and plug into the original equation. So it'll become y equals 6 plus 5 times negative 2. So y equals negative 4. So the solution to the system is negative 2, negative 4. Pause the video and try the next example on your own. In this example, our two equations are 4x minus 7y equals 16 and negative 2x plus 6y equals negative 18.
Now, the first thing we need to do, since there isn't a variable by itself, is decide which variable to solve for. And again, the question we kind of want to ask ourselves to guide ourselves is there a variable without a coefficient? However, if I look, I have a 4, a 7, a negative 2, and a 6. So they all have a coefficient, which means I'm going to have to go with the next statement, which says that if not, select the variable with the smallest coefficient that evenly divides into the other terms. Now, the smallest coefficient number-wise of 4, 7, 2, and 6 would be this negative 2, and we can see that it divides evenly into our other terms of 6 and negative 18, so that's the variable we're going to select to solve for.
So in order to solve to get it by itself, I would have to first move the 6y over. So I subtract 6y from both sides to get negative 2x equals negative 18 minus 6y. Then to finish getting x by itself, you would divide both sides by negative 2 to get x equals 9 plus 3y. Now you're going to take this entire expression of 9 plus 3y and plug it in for x in the other equation. So it'll become 4 times 9 plus 3y minus 7y equals 16. In order to solve, you first need to distribute. So you get 36 plus 12y minus 7y equals 16. Combine like terms to get 36 plus 5y equals 16. Subtract 36 from both sides to get 5y equals negative 20. Divide both sides by 5 to get y equals negative 4. Now you can substitute this value of negative 4 into the original equation. So you'll get x equals 9 plus 3 times negative 4 to become x equals negative 3. So the solution to the system is negative 3, negative 4.
Now we will discuss the special cases of solving systems of equations by substitution.
If the system results in a true statement, then there is infinitely many solutions, because it's always true, so any number would work. An example that you may see is if you see something like 5 equals 5, then it means it's a true statement, so it's infinitely many solutions. If the system results in a false statement, then there is no solution, because there's no set of numbers that will ever make it true. So if you see something such as 4 equals 0, which is false, that would mean it's no solution. In our first example, our two equations are x plus 3y equals negative 11 and negative 2x minus 6y equals 22. Again, in order to solve the system, we have to choose a variable to get by itself. So in this case, the x is the smallest variable, so we're going to solve to get that variable by itself. In order to do so, we'd have to subtract 3y from both sides, and we'd get x equals negative 11 minus 3y. And since the x is already by itself, I can take this entire expression and plug it in for x in the other equation. So you'll have negative 2 times negative 11 minus 3y minus 6y equals 22. Now to solve, you have to first distribute. So you'll get 22 plus 6y minus 6y equals 22. Then if you get combine like terms, you'll get 22 plus 0y equals 22. Now that 0y can really be just written as if nothing's there. So it really means 22 equals 22. Now since this is a true statement, this means that there is infinitely many solutions. In our next example, our two equations are 2x plus 10y equals 7 and negative x minus 5y equals negative 1. Now again, we have to choose a variable get by itself. In this case, since the negative x has the smallest coefficient, that's the one we want to solve to get by itself. So in order to get it by itself, I first have to add 5y to both sides. So you get negative x equals negative 1 plus 5y, and then divide both sides by a negative 1 to get rid of that negative in front of the x. This becomes x equals 1 minus 5y. Now you can take this entire expression and plug it in for x in the other equation. So it becomes 2 times 1 minus 5y plus 10y equals 7. To solve, we'd have to distribute. So you have 2 minus 10y plus 10y equals 7. The negative 10y plus 10y becomes 2 plus 0y equals 7. And again, we don't have to write that 0. So it becomes 2 equals 7. Now since this is false, this means that there is no solution to the system.